Okay, ladies and gentlemen, today we are focusing on Chapter 5.4, which is graphing compound inequalities. If you take a look at your goal sheet and you notice that it's pretty empty, take a minute. This one's totally up to date. Make sure all of your homework scores are up to date. We have taken a quiz on both of these items. And as you saw, we just took a quiz on these two items, and we'll get back to you here soon. So make sure your goal sheet's totally up to date. All right, so let's talk about this idea of a compound inequality. So think about the words and or. A compound statement is made up of two simple statements connected by the word and or. So let's take, for example, Miss Martin. We can say that Miss Martin teaches 7th grade English and 8th grade English. And that would be a true compound statement. We could also take myself, and we could say Mrs. DeHaan teaches 8th grade algebra or 7th grade pre-algebra. And that would still be true even though I don't teach pre-algebra anymore. All right, let's try something here. So I've got these two situations here. The fact that a spider has 8 legs, which you know is true, and that a dog has 5 legs, which you know is false. So if we put these together with the word and or with the word or, we can decide whether the statements are true or false. So take this first one here. A spider has 8 legs and a dog has 5 legs. Even though this first part is true, because the second part is false, the whole statement is false. Let's look at the second one. This one uses the word or. It says a spider has 8 legs or a dog has 5 legs. The first part is true, the second part is false, but the whole statement is true, even though there's a false part because of that word or. It's one or the other, whereas and means both. All right, let's try this with numbers. So we're going to determine whether the statement is true or false. I've got 5 is greater than 0, and we know that to be true. And I've got -3 is less than 0, and we know that to be true. And because it says and, the whole statement is true. Try the second one yourself. All right, so -2 is greater than -3. That's true. Or 0 equals 0. That's true. So even though they're both true, we've still got that or going on there. So the whole thing is true. Pretty easy, right? All right, let's take a look at what the graphs of compound statements look like. So we're going to graph the solution set of x is less than 2 and x is greater than or equal to -1. So we have to keep in mind open circle and closed circle and all of those little things. So let's draw our number line. We're going to need the numbers -1 and 2. So I got -1, 0, 1, 2, and I'll put 1 above it, 1 below it there. Okay, so for the first one, I'm going to do this one in green. We've got x is less than 2. So that's going to be an open circle at 2. And we shade where it's less than. Now let's do the other one in blue. We've got x is greater than or equal to -1. So that's a closed circle at -1. And x is greater than would be in this direction. Now comes the tricky part. Our final answer, because it says and, we're looking for the place where they overlap, and only where they overlap. So my final solution, actually, let me just re-sketch this real quick. My final solution is an open circle here, and a closed circle here, and the place where they overlap. So there is no shading outside of where they overlap. All right, let's try the second one. This is an or. Let's make our number line. We've got a is less than 5, or a is less than -1. So we've got -2, -1, 0, 1, 2, 3, 4, 5. Oop, we gotta make it a little longer. 6. Okay, so a is less than 5. So that's an open circle, shading where it's less than. And we've got a is less than -1, open circle, shading where it's less than. Now this one says or. So is 4 an answer for either or? Yes, it is. Or means it doesn't have to be just where it overlaps. It can be everything. So our final answer on this one would be a circle at 5 and everything below 5 shaded, because everything below 5 works for at least one of those two options. All right, so what I'd like you to do for homework tonight is to work on a worksheet. There's a whole bunch of graphing there for you, but I'd like to show you one more example. If I have x is less than 2 or x is greater than 5. This is another common example of an or. So I've got 1, 2, 3, 4, 5, 6. We're going to have an open circle at 2 shading less than, and an open circle at 5 shading greater than. So my final solution here is both of these segments, because it's an or. It can be in either place. But imagine if this had said x is less than 2 and x is greater than 5. What would the solution to that be? That's your challenge. What do you think the solution to that would be? If you think you have an idea, go ahead and graph it up and give me a show. That's a challenge. Let me know what you think. So, working on that worksheet. I believe there's 12 problems, if I remember correctly. Should be pretty simple. We'll check it in class tomorrow. Good night.